Hello, fam. This is our Unit 4 overview. I kind of feel like we've been in this unit for 5 years now. I don't think Christmas break did us any favors in terms of this unit. So I decided, since I needed a little bit of a refresher on what we have gone through, it may be helpful for you guys to also have the same refresher. So on this side of this cardstock is an overview of all of the things that we've talked about in this unit. Now, this is not a detailed overview. This is not anything that I would use as like a flashcard or the only thing that I studied for this exam, but this is a really good place to have, or to a really good thing to use as a quick reference for all of the topics that we've covered, because we've covered quite a bit in this unit. Then on the back side, I have gathered and put together for you all of your interpretations that you may need to make or be asked for on this unit. So hopefully this makes things a little bit easier and quicker for you, because you won't have to be flipping back and forth through your notebook. This would probably be the most use to you if you went through it before you did your reviews. If you have already done your reviews, that's great. Hopefully this just kind of brings everything together for you and just makes the skills that you have a little bit stronger and, you know, ties some things together for you. Okay, so we'll start at the very beginning of this unit. This overview does go in the order that we learned them. So the first thing that we talked about was the difference between an explanatory variable and a response variable. So explanatory variable, that is going to be your X variable. And response variable is your Y variable. Your X variable may help you predict or estimate or explain changes in your Y variable. So may help you predict, explain, estimate Y. Response variable is the outcome we are measuring. One thing that may help in this case is to add in an example of an X and a Y that you felt pretty good about. So we talked about it so much, I feel really good about the used truck example. So for me, I may want to add in as a reminder, okay, an explanatory variable is something like miles driven. And a response variable is something like price. If you have an example that you like better or one that's more complicated that helps you think about more difficult ones, then add them in. Add in as many as you want, but I would maybe put at least one in just to jog your memory. When you have two variables, an explanatory and a response, you can make a graph out of them. You put the explanatory on the x-axis, the response on the y-axis, and it builds a scatter plot. When looking at that scatter plot, we are examining the strength, direction, and form of the scatter plot. That's how we determine if there's a relationship. So I have put these in the order that you usually say them when you describe a relationship. You usually put strength, direction, and form in that order. So strength is how closely the points follow a clear form. So if you go back and look through our notes and look at the scatter plots that have the highest strength, you will find that they are the ones that are closest to a specific form. So here, this is a very strong relationship because these points are very close to this curved line. This is a strong relationship because these points would be very close to a straight line. There's another example here. I don't know how well I'll be able to show you, but it's these guys. So this is a good example of why this is not a detailed review. It's an overview, because you have to see that in your mind. You have to see those points really close to the curved line or the straight line. Okay, so next up would be direction. The direction. Remember that this is described using the words positive or negative. A positive relationship is when x increases and y also increases. So both are increasing. A negative relationship, we start out the same way. X is increasing, but in this case, y is decreasing. So we have the strength, the direction, then we have the form. Is it linear? Is it curved? Is it nonlinear? Is it a random scatter? So form is kind of like shape. So we have two variables, explanatory response. We can plot those to make a scatter plot. And scatter plots can help us see a relationship between two variables. So when we see here describing scatter plots, we can also think about this as describing relationships. And on the reverse of this page, you'll see here, describe the scatter plot or association or relationship. All of those things start with strength, direction, form. So if you're asked to describe the scatter plot, association, or relationship, you say there is a moderately strong, positive, linear relationship. Here, for the correlation coefficient, it's a very similar description. Okay, so now, if we have a scatter plot that shows a linear relationship, we have a correlation coefficient that we denote with the letter R. So the correlation coefficient measures the strength and direction of linear relationships. Linear relationships. This only applies to scatter plots or x and y variables that follow a linear form. If I flip back to those same two definitions, or I shouldn't say definitions, interpretations, remember how I said these two are very similar? The only difference is that when we describe correlation, we know that the form is linear. So notice we have strength, direction, and the given that it's linear. Up here, it could be curved or straight. So R only applies when you have a linear association. When you have correlation, you have a bunch of properties that go along with correlation that we need to make sure that we're aware of. Most of the time where you will see this in an exam is the multiple choice questions. So you want to look out for these things in the multiple choice. So first thing, correlation measures the strength of linear relationships.
Alexia Crandall, please call the main office. Mrs. Crandall, call the main office.
This is Crandall. Switching the x and y variables does not change R. So a good example of this would be the Da Vinci problem. You could use height as X and arm span as Y. You could also switch that and say arm span is X and height is Y. It doesn't matter which one is X or Y, the relationship between height and arm span will be the same. I guess I shouldn't say it doesn't matter which one is X or Y. It does, you do need to know which one is the explanatory or the response. But if for some reason you switch them, the correlation would still stay the same. R has no unit of measurement. Which means that converting from inches to feet doesn't change the relationship. Converting from seconds to minutes doesn't change the relationship. So you want to think about it like if you are looking at the race time, looking at a relationship between, I don't know, like leg strength and race time or something. If you're looking at it in terms of how long it takes you to finish the race, it doesn't matter if you describe that time in minutes or seconds, it's still the same amount of time. You still finished the race at the same speed, at the same time. You're just measuring it or describing it differently. So changing the unit of measure does not change the relationship. Doesn't change. Same with like length. The changing your height from centimeters to inches doesn't change your actual height. It just changes the way you describe your height or what you're describing your height with. Both variables must be quantitative. Quantitative. So we would never see a scatter plot of gender and height. We would never see a scatter plot of gender and height. That just does not make sense. Correlation is a number between -1 and 1. And I thought that this would be a good place to remind ourselves what the guidelines are for what we would describe as strong, moderate, and weak. One thing to keep in mind here is these are not hard and fast rules. So for instance, for strong association, what you're looking for is a positive or negative about 0.8 or 0.80 to about 0.99. A 1 would be a straight line, a perfectly straight line. So if you got one that was 0.79 and you said that was a strong relationship, you're not going to be marked wrong because you said it was strong, but the guideline is 0.8. That's close enough. So you do the best that you can. If you can remember these values, awesome. But if you can't, just know that for it to be a strong association, it's got to be pretty close to 1. Moderate association is a positive or negative, and the range is 0.50 to 0.79. And then a weak relationship is about 0.01 to 0.49. If you have an R of 0, that means that there's no linear association. An R of 0 means there's no linear association. There still could be association though, so let me give you an example. This relationship would give you an R of 0. But obviously there is a relationship between these variables. So this is strong association. It's just not linear association, so you don't have R. So we have to make sure that we distinguish. R equals 0 doesn't mean there's no relationship at all. What it means is there is no linear relationship. Okay, we're down to our last two. Correlation is not resistant to outliers. So that's our influential points lesson. So notice once again, this is an overview, not all the details. We had a whole lesson on this bullet point, but in this overview, it's just one bullet point. And last, correlation is not a complete summary of the data. So correlation doesn't tell us everything there is to know about the data set. So for instance, if we got an R of 0, that would just tell us there's no linear association, but look at what's happening. There is more to this association than just saying R is 0. So it's not a complete summary. So we started with our X and Y variables that have to be quantitative. We can plot the X and Y variable against each other and see if there is a relationship. If we happen to have a linear relationship, we have a descriptor for that called R and some properties about that value. We can also find a least squares regression line if our relationship is linear. Now notice I have this little asterisk here. That's because one of the important things to remember is that the least squares regression line minimizes the sum of the squared residuals. So we talked about some properties of the least squares regression line. This was one of them. It minimizes the sum of the squared residuals. The other one is that it includes the point mean of X, comma, mean of Y. And then the last one was that formula that you could use to find the least squares regression line. So on our overview, this is just one section of our one sheet of paper, but in our notes, remember, we had a whole lesson on the least squares regression line, and it included the description of what that actually is. So description of what it actually is. It included how you calculate, and then down here it talked about this property. So make sure you know this is not a detailed review, this is an overview. Okay, we use the least squares regression line to predict or estimate Y for a given value of X. So if we want to predict a Y value, we would plug it into this equation. Remember, Y hat, it's really important that we distinguish this is predicted Y. The letter A is your y-intercept. That is when X is 0. And then the letter B is your slope. So for every 1 increase in X, what is Y doing? Remember, when you want to predict values for Y, you cannot use X values that are outside the interval of observed values, because this is called extrapolation. This is called extrapolation. So the magazine problem is a really good problem to discuss this. We had a problem where we were predicting the number of magazines published based off of the year. We had data for the years 1988 to 2002 or something like that. We would not want to predict the magazines published for 2015 because we don't have data for the year 2015. We only have data for the years 1988 to 2002. So you can only predict for values of X that are within the observed values of X that you have. So the easiest way for me to think about that is the year example. If I only have data for a certain amount of years, I can't predict for anything outside of those years. Same with the miles driven. If I only have data for miles driven 0 to 50,000, I can't predict the price of a car that has 100,000 miles. I only have data for 0 to 50,000. When you are answering a question about extrapolation, so on this reverse side, we have our sentence frames or our interpretation or response for when we're talking about extrapolation. I left a little room up here because when you're asked about extrapolation, it doesn't always look the same. So for instance, on the first review that you got, you had this question that says, predict the fastest serve of a professional tennis player who is 1.7 meters tall, then comment on the reliability of this prediction. This is asking about extrapolation. This prediction is not reliable because we are extrapolating. In this question, this is the second review, the very last question, would it be reasonable to use the fitted regression equation to predict the fuel consumption for a train if the train had 65 rail cars? This is extrapolation. They're trying to get you to recognize, no, it would not be reasonable to use the line to predict because this would be extrapolation. So I left room on the top of this sentence frame or phrase to memorize because I wanted you to be able to write here something that would help you remember that it's not always going to be asked the same way. So for instance, you need to answer the prompt or repeat the prompt and then say, because we are extrapolating. So on that first problem that we looked at, the prompt was, would it be, just kidding, comment on the reliability of this prediction. So answer the prompt or repeat the prompt would be, this prediction is not reliable because we are extrapolating. For this one, would it be reasonable to answer that, answer the prompt or repeat the prompt? It would not be reasonable to use the LSRL to predict this value because we are extrapolating. And then you can go into the phrase to memorize. So if that doesn't help you at all, you can just leave that part of yours blank. But I wanted to leave something there to somehow indicate that it's not always going to look the same, but you can kind of follow the same pattern, maybe? I don't know if you'd call that a pattern. Okay, we have our regression line. Once we start making predictions, we can talk about residuals. So residuals is the difference between your actual Y and your predicted Y. So residuals are the difference between your actual and your predicted. The least squares regression line is going to minimize that average distance or that average difference. So it will minimize the sum of the squared differences between the actual and the predicted. One thing to note here is that if you have a strong relationship, residuals are small. If your relationship is strong, your residuals will be small. Because remember, the strength of your relationship is how close are the points to the prediction line. If your points are very close to the prediction line, that means that your residuals will be small and your relationship is strong. So maybe over here we could add something in like small residuals. small residuals. But remember, residuals only apply to linear relationships. If you are asked about residuals, the easiest thing to do for me personally is set up these 4 things. X, Y, Y hat residual. X and Y will usually be given to you. Y hat you can calculate by plugging X into LSRL. And when we say X, we mean the X that they gave you. This would mean that they also have to give you the LSRL, which typically they do. I don't think I've seen a problem on residuals where they don't give you the least squares regression line. So you'll usually be given X and Y. You will calculate Y hat. And then your residual will be Y minus Y hat. One thing to keep in mind here is that if they give you any 3 of the 4, you can find the 4th one. If they give you any 3, you can find the 4th. Or even if they just give you X, Y, you can find the bottom 2, because you can calculate Y hat. So just keep in mind, they could ask you to find any of these. They could ask you to find X, Y, they could ask you to find Y hat, or the residual. Know that they will always give you enough information to use this equation to solve for whatever is missing. Residual plots are the most important tool for deciding if a linear model is appropriate. If you are being asked to determine if you should use linear regression, or if the linear regression was appropriate, what you are looking for is the residual plot. It's the most important deciding factor. If they ask you if a linear model is appropriate and you don't say something about the residual plot, you will get the question wrong. A linear model is appropriate if there is no leftover pattern in the residual plot. So that means the linear model that you used captured the relationship between X and Y. If it captures the relationship, that means that what you have left over is random scatter. If what you have left over is another pattern, like a curve, that means you didn't capture the whole relationship because you still have that curved relationship left over. So you want to look for no pattern or random scatter. Now our last thing is computer output. So remember, for computer output, this isn't necessarily any new concept or idea. Computer output, you just need to know where to find the variables and the descriptive statistics that we care about. So remember, it's always the 2 numbers under coefficient, S and R squared. This is always the descriptor for your X variable. And then the last thing is you can use this R squared to find R. Remember, it's going to be plus or minus the root of R squared. And it matches sine of slope. You could add in here that R needs to be written as a decimal. That may be helpful to you. In fact, it may be helpful now that we have gone through this entire page. If you like this format or this overview, it could be very helpful for you to go in and add in the details if you wanted to. You could add in the detail that this needs to be a decimal. You could add in random scatter. So use this as it works best for you. In the very least, hopefully it just brings the whole unit together and gives you a quick snapshot of all of the things that we have discussed. Remember, on the back side you have your phrases to memorize. Now obviously you can't use this on your AP exam. They're not going to let you take it in, so you can't use it on this exam, but it will, I personally think, help you in the process for studying. Then the last thing is, remember, this is not the details. This is the overview. So you cannot just use this to study from. You cannot just use this to study from. You have to remember the details. This should just jog your memory. Okay, this is my least squared regression line. Okay, what are all the details behind my least squared regression line? This is extrapolation. What are all the details behind that? So hopefully this was helpful to you. Next up are the solutions to the 2 reviews that you have. I also have flashcards that I will put up. Your flashcards are not required at all. I just know some of you guys like to see them, so I will put the flashcards up that I have. And then if I have any tips or tricks for studying for this unit, I will make a video on that for you as well. Okay, that's it. Love you guys. If you have questions, email me, send me a video, come see me, whatever works best for you.